see the next few videos on the block and block questions, because it is very important to understand the full concept of block and block. It will take more than 1 hour. Hello, welcome back. Let us do the next one. Example. Let us make the question a little bit more conceptual. Okay. So in this case, two blocks are given like this. This is the surface. Ten kg, 15 kg. A, B, F. It says two blocks A and B are resting one over another on a frictionless surface. So this surface is frictionless. This surface is mu equal to 0. Mu equal to 0. The coefficient of friction between them are 0.3. That means between block A and block B, the coefficient of friction is 0.3. Block B is pulled with a force F. Block B is pulled with a force F. Find the maximum value of F for which both blocks will move together. Find the maximum value of F for which both blocks will move together. So how to solve this kind of question? So he has asked what is the F max for which the blocks will move together. Always remember, for this kind of thing, when till that point the acceleration of block A is equal to acceleration of block B, till that moment the block A and block B will be moving together. What do I mean? I am pulling this with a force. Okay, this block will move in this direction, and along with him it will take this block also in this direction. But if I pull it with a very high force, then this block will move at a very fast acceleration, very high acceleration. This block will not move with such acceleration, so this block will fall from the block. But we want what is the maximum value of force for which this block will not fall. These two blocks will be moving together. So first of all, let me find for what value of force the block will start to move. See, one resistance is given like this. What I have told you, that if there is that movement of this block depends on the movement of the block B, depends on the frictional resistance given by the surface on A. That means FDS, frictional resistance given by the surface on block B, or frictional resistance on block B by the surface. Whatever the value of it, this should be the resistance. After, if the force is greater than FDS, then this block will move. Okay. It doesn't depend on this frictional resistance, only this one. So if this F is greater than FDS, then it will move. What is the frictional resistance offered by the surface on B? See, if I draw a free body diagram of block B, this is block B, 10 plus 15 is 25. 25, I am taking it as 250 Newton. 250 Newton. Okay, in upward normal is acting like M. Okay, and this should be the frictional resistance, that should be FSFBS. So that should be equal to mu times N. Mu is 0, times 250, that is 0 Newton. It means if this force is greater than 0 Newton, then this block B will start to move. Try to understand my point. This block B will start to move at a force of greater than 0 Newton. Okay, but when it is starting to move, this will also move with him. But after a particular value of f, this will move at a faster acceleration than this. At that time, they will not move together, they will move separately. What is the value of that? So we will know that f min is 0. What is the f max? F max is, say, what is the frictional force, that the maximum frictional force that can be given by block B on A, force on block A by B. The maximum resistance can be, the maximum frictional force can be mu times N. What is the mu? 0.3. What is the N? 10 into 10, 100 Newton. Upward is normal. So mu times N is equal to 0.3 into 100. So that is 30 Newton. Okay. So now in this case, the maximum resistance, the maximum force that can be given on A by B, F A B, is equal to 30 Newton. Okay, this is the case of maximum. In this case, we can take in the opposite direction. On block B, there will be a resistance given by block A on B, that is FBA, force given by force on B by A. For equilibrium, that is also 30. What is this value? This is 0. This is F. Now, for the 30 Newton force, what is the acceleration? What is the acceleration of block A? So we know F is equal to mass into acceleration. Okay, I'm talking about the acceleration of block A. That means what is the maximum acceleration the block A can achieve, or the maximum acceleration the block B can offer to A. This is because of the 30 Newton force. Whatever acceleration comes, that is 30 Newton force should be equal to mass of block A, that is 10, into acceleration of block A, mass of block A, acceleration of block A. So AA, acceleration of block A, is equal to 3 meter per second square. Okay. If till that moment, I have told you, till that moment, acceleration of A is equal to acceleration of block B, they will move together. After that, they will not move together. So I can say till the force, whatever the amount of force is causing, can cause the acceleration of block B, to be 3 meter per second square. Till that point of force, they will move together. So right now, from free body diagram, we can say F in this direction, resistance in this direction, minus 30 minus this one 0, is equal to mass of B into acceleration of B. Okay. What can be the maximum acceleration? That is 3. So this should be also 3. So F minus 30 should be equal to mass of B 15 into acceleration of B 3. This is the maximum acceleration. So F should be equal to 45 and 30. 45 and 30 is 75 Newton. So for a force of F is equal to 75 Newton, they will move together. So what is our conclusion? The conclusion is 0 to 75 move together, greater than 75 move separately. We'll see one more problem like this. Okay. Now if I say that the question is same, the question is same, this is A, B, this is 10 kg, this is 15 kg. The only difference is this is 0.3, say this is 0.3 and this is 0.2. Okay, what I am changing is I am changing this value. This was initially frictionless, it was 0, now it is 0.2. So I am telling about F force max. For what maximum amount of force they will move together. So first of all, find what is minimum force for which they will move, and what is maximum force for which they will move together. Now if this is the question, how to solve it? I've told you that the minimum force depends on the FVS. Okay, the maximum depends on both of them. So always make this concept clear that if you pull, suppose you are taking two blocks, okay, one over another, you are pulling this block. Only thing, the movement of the two blocks depends on the contact, the frictional force resistance between the contact surface and the bottom, the block which is at the bottom. It doesn't depend on this frictional force. So see clearly, don't make your concept wrong. Here are the two blocks, okay, A and B. This is 10 and 15. This is pulled with the value of F. What is the resistance? This resistance on the horizontal force given on A. First of all, let us find what is the horizontal force given on A by B. That is F A by B what should be the value of it? The value of it is equal to mu times n. The mu is 0.3. The n is 100 Newton. This is the normal. So mu is 0.3, n is 100, that is equal to 30 Newton. From the bottom, 10 plus 15, 25. 25 into 10 is 250. 250 acting like this. And the top n is acting like this. Okay. So here will be some resistance. Okay. This resistance is 0.2. So mu times n, 0.2 into 250. 0.2 is 1 by 5 into 250, that is 50 Newton. 50 Newton is the value in this direction. What is the value in this direction? F on B by A, and that is 30 Newton. Okay, and this force F minimum. What is the value of F minimum for this for this block B to move in this direction? F minus 30 minus 50 equal to 0. F equal to 80 Newton. Okay, clear? That is what I am trying to tell. This is wrong. This is not right, because when you consider the movement of this force, the minimum amount of F, don't take this value, because the full amount of frictional resistance will not be generated. This should be 0. Why and why? I am telling you again and again, don't consider the force in case of F minimum. Consider this to be 0. Okay, so F should be, minimum should be F, I am writing it like this, F minus only 50, that should be equal to 0. F minimum, and this is 50, only these two equal to 0. So F minimum is equal to 50 Newton. So for any value between greater than 50 Newton, they will start to move. So we have got a conclusion. For F less than 0, they will not move. For F, or F where F, not this, F in between 0 to 50, F equal to 0 to 50 or less than 50. F is equal to less than 50 I'm writing. I'm so sorry that I'm writing it again and again. F less than 50, they will not move. Okay. After F, any value greater than 50 to some value, they will move together. What is this? Is what is 52 value? The 52 value, that value we should find. It means what is the maximum value? See, I'm talking about this. Suppose in this case, the maximum value means whatever value can be given. This is what we have already found, that 102 0.3, that is 30 Newton for this. This is the maximum value. Okay, for which this block will this maximum value can be offered by block B on block A. So this is maximum value, and the acceleration of this block A can be because of this only, because there is only one force. So this force will be causing some acceleration of block A. Is it clear? This force is 30. Force is equal to m into A. In this case we can say force is 30 is equal to mass of A into acceleration of A. Is it clear? Mass of A into acceleration of A, and that is 30 equal to mass of A is 10 into acceleration of A. So 30 by 10, that is A of A equal to 3 meter per second square. When till that point A of A is equal to A of B, they will move together. Clear? After that, see what is the force, what is the resistance in this direction. On this is A, this is B, writing it here. So this is 10, 15, 250. 25 into 10 is 250, acting like this. Normal is acting upward like this. Okay. One force is 30 in this direction. One force is acting like this in this direction. What is that? 250 into 0.2. Mu times n. Mu is 0.2. N is 250. That is 50 Newton. 50 Newton is the force. And in this direction F max is the force. Okay, so I can say that F max minus 50 minus 30 is equal to mass of B into acceleration of B, and for A of A is equal to A of B. What I can write? A of B or A of A is equal to A, and that is equal to this 3 meter per second square. So F max minus 80 is equal to MB. MB is your 15. MB is 15 kg. 15 into acceleration of B. Acceleration of B is maximum 3. So 45. F max is equal to 45 plus 80, 125 Newton. 125 Newton. So for 125 Newton, they will move together. Till the point the acceleration is 125 Newton, they will move together. So I'm writing it in here, 50 to 125. They will move together. Okay. Okay. Let us see with an example what will happen if the force is greater than F. Forcing F is greater than 125. They will move separately. For any force greater than 125, they will move separately. Let us take this example. Suppose instead of 125 or F max, I am writing it to be 200 Newton. Let me see what happens. If it is 200 Newton, then the force generated in here, that maximum resistance, the maximum force can be 30 Newton. Because of the 30 Newton, what was the acceleration? We have already seen that the acceleration, the maximum acceleration of A that the A can achieve is 3 meter per second square. This is the maximum acceleration A can achieve. Okay, in this direction also 30 Newton. 30 Newton will be generated this direction. 50 Newton will be generated. This is F max. Okay, or no, F max, not F max. This is 200 Newton. 200 Newton. This is 200 Newton. Okay, so we can say now 200 in this direction, 38, 50, 80 in this direction should be equal to mass of B into acceleration of B. Okay, so mass of B, it is 120 divided by mass of B is 15. 15, that is equal to A of B. So 15, 120 divided by 15, that is A of B is equal to 8. 8. So 8 meter per second square. A of acceleration of A is not equal to acceleration of B. So we can say move separately. They will move separately. See, we're coming in here. One more concept now. Let us talk about the most important concept. For F equal F less than 50, it was not moving. For F in between 50 to 125, they were moving together. For F greater than 125, they were moving separately. Okay. So what will happen if this F is in the range of in between 150 and 125? Suppose this is the block A, this is the block B. I am giving a force in here 0.2, 0.3. 0.3 it is what I have given so far. 0.3. Now I am giving this F to be in this range, in between 50 and 100. Suppose this is 100 Newton. What will happen? Then this is A is 10, this is 15. Clear? Now, if I take this one, let me do this. This is 30 generated. Here it is. The direction I have taken wrong. This is 30 in the opposite direction. 30 in this direction. And this is 30 in this direction. And this is 50 in this direction. We have already seen this. Okay. And this is 100 in this direction. Now, because of 30, acceleration of A was 3 meter per second square. This one was the maximum acceleration given or possible for block B. This is A, this is B. For block B, 100 minus 50 and 30, 80 equal to the acceleration of B or mass of B into acceleration of B. So mass of B is 15. So 20 is that divided by mass of B, 15. That is equal to A of B. That is 4 by 3. That is 1.33 meter per second square equal to A of B. Now see what is that. What we have done. This is what I was talking about. I have pulled, see the concept. I have pulled this block with a force of 100 Newton. Now this block is moving with an acceleration of 1.33, and this block is moving with an acceleration of 3. That is the main concept. That is where you will get confused. This is the kind of concept, the kind of question that can be asked in exam like GATE. Because questions will be conceptual. This is possible? No. This is not possible. Then where we have done the mistake? I have done this mistake because I wanted to show you what mistake you can do in your exam. The mistake is this one. See what happens. I have already told you about static friction and dynamic friction. The graph was somewhere like this. What I want to say is static friction can be a variable thing and dynamic friction is a constant. Friction limiting is in here. In our case, the limiting frictional force is 30. It means this is 30. But any force value than any value of force less than 30, that can be a variable. Why I am telling this? I am telling that within the range of 50 to 25, they will move together. They will move together, and if they move together, then there is no relative motion between block A and block B. There is a relative motion between the surface and block B, but there is no relative motion between A and B. If there is no relative motion, in that case static friction comes, not dynamic friction. Dynamic friction constant when this is the acceleration of this is somewhere, it is different, this is different. It means the maximum value of this frictional resistance is achieved. But from our question we have seen that in between this range the maximum frictional resistance will not come. What value will come? That value will be a variable. That value is a variable. So we are somewhere in here. We are not in here. But we have taken the value of the frictional resistance of this. We have taken this 30, this value. This value will come only then when there is a relative movement between A and B. But there is no relative movement between A and B for this range. And I am talking about this range. The range is less than 125. So there is no relative movement between A and B, and when there is no relative movement between A and B, full frictional resistance or full frictional force will not come. You got my point? Okay. The frictional resistance between this block A and block B can be anything, and this will be like this, anywhere between 0 and 30. What is the frictional resistance? That we will have to find out. What is the acceleration of A and B? That we will have to find out. So for this kind of question, don't do this mistake. Always do this. For this kind of question, always do this. Write this value as force, frictional force on A by B, frictional force on B by A, frictional force on B by, because this is a variable, this is something X that is not known. From this, now we can solve it. Say we get one equation, FAB, what is that? That is mass of A into acceleration of A. Mass of A is 10, acceleration of A is A. In the second case, here 100 in this direction, 100 minus FBA minus 50. Okay, this will cause a mass of B, that is 15 into acceleration of B. Clear? If these two blocks are moving together, then FAB has got to be same as FBA. If they are moving together, then this force comes. So FAB is equal to FBA, and FAB is 10 into AA. So 100 minus 10 into AA is equal minus 50 equal to 15 into AB. Now I am telling about the both of the blocks are moving together. If they are moving together, when it is possible? When their acceleration is equal. It means when the acceleration of A is equal to acceleration of B, then only it is possible. So now what I can write, 100 minus 10 times A minus 50 minus 15 times is equal to 15 times A. So if I do it in this direction, so this is 50 is equal to 10A 15A, that is 25A. So A is equal to 50 by 25, that is 2 meter per second square. So this is 2 meter per second square. It means for a value of the friction, the force of your, what is that? Correct. Okay, 2 meter per second square, for a value of 2 meter per second square, they will move together and at an acceleration of 2 meter per second square. Now we need to see what was the resistance between these two blocks. We have assumed it as 30 initially and we have got the wrong value. But now we can say, we can find the value. How? See, FAB is equal to 10 into AA. So 10 into AA means 10 into 2, that is 20. That is 20 Newton. So FAB is 20 Newton. So the maximum value that can come was 30, but now it has come 20. So from our graph, you can say this, it was like this, and we were in this region. This was the maximum value 30, and we are somewhere in here of 20. So it is a variable, that is why it is coming. Clear?